So this is competition 2 from the 2014-2015 Mathletics year, and this is the second page of the written round. And we're going to start with a problem that I have a little concern on, but I'll explain it in a second. So we say that there are 13 points labeled evenly on a number line going from A through L. The coordinates of point A and L are 1 and 8 respectively. So I have a number line, and I'm labeling these 1 and 8. Now, I'll tell you my concern right now. L is the 12th letter in the alphabet, and it states 13 points here. So I have some understandable concerns with this problem, but we are going to go ahead and make the assumption that there are 13 spaces. Okay? So that is the assumption I'm going to make, and I'm going to do the problem using that. And on my number line, I clearly see that G is the, well, how far is G from A? It's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I've jumped 6 spaces over, right? So right now I know that G is 6 of this distance from A. And I'm also pretending that this is the 13th space. So, and in those 13 spaces, I have traveled, so here's my 13 spaces. I have traveled 7 numbers. So that means I have a slope. I mean, this is just like a table, right? That means I have a slope of 7/13. And I need to go 6 of those 13ths. So I end up with, watch me multiply that, 42 over 13, which is also equal to 3 3/3. Sorry, 3 3/13. Well, you might think that's the answer, but wait, there's more. Since we are going 3 3/13 spaces, we have to see where we started. Well, we started at 1. Therefore, we've got point G is my 3 3/13 plus my 1 for 4 3/13. All right, how many digits? 13. How many different 4-digit numbers can be made using the digits 6, 5, 4, 2, 1, and 0 only once? Now, you might be tempted to call this a permutation, but wait. There is something we have to take into account, and I'm going to cheat just to make this faster because I have to get to Anya's basketball game. If I have a 4-digit number, can I put a 0 as the first digit? And the answer is unequivocally no. So, keeping that in mind, and I think that's what the biggest error is, how many different options do I have for this digit? Well, I have 1, 2, 3, 4, 5. I have 5 different digits I can put in there. How about here? Well, I still have 5 different digits, so I have the 5 remaining digits that I have not used, because now I can put a 0 there. That means I can put 4 here and 3 here. 5 times 5 is 25. 25 times 12 is 300. If the odds that an event will occur are 2 to 7, what is the probability the event will not occur? Express your answer as a common fraction. All right, so this is a part-to-part ratio. 2 times it will occur, 7 times it won't occur. Therefore, I have a grand total of, what is it? It will not occur. So I have 7 not occurring, and I have 9 total, because twice it'll occur, 7 times it will not occur, for a total of 9. So this was a question of part-to-part versus part-to-whole ratios. That's not whole, that's won't occur, right? All right, so problem number 15. express, oh, I love this, product of primes. This is just prime factorization, folks. That's all it is. So we have 6, 3, 9, and these are all of these digits are multiples of 3, therefore we know this is divisible by 3. So that's the first place I'm going. So we get 2, 1, 3, and 2, 1, 3, well, 2 plus 1 plus 3 is 6, which is divisible by 3. So I'll put another 3. So 3, I get 7, 1. So 3 times 3, so that's 30 squared, times 71. Now, incidentally, as product of primes, it's one of the few places, that in scientific notation, where you use the multiplication x. So 3 squared times 71 seems too simple, right? All right. 16. Find the smallest 5-digit palindrome, which is a multiple of 11. All right. Now this problem is a little tricky. First, a palindrome. Palindrome is a number that goes that is the same backwards and forwards, right? And so, for example, 121 is a palindrome. It's also divisible by 11. So we want to find the smallest 11-digit palindrome possible that's divisible by 11. Now, I may not do this the most efficient way. Probably not. But let's go ahead and give it a shot. So the first thing I would say is obviously we're going to have a 1, blank, 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 and a 1. We have to have a 5-digit number. Clearly, we want this to be a 1, which would make this a 1. And it would make more sense for us if we had 0 and 0. And so really we're shooting for this number. So the smallest number that we have is 0. I'm going to work in a different color. And is that divisible by 11? Well, geez, I don't know. So I would go ahead and divide it by 11. So 11 goes into 109 times with a remainder of 1, and that does not go into 101. So let's try 2, or let's try 1. That's a remainder of, now we have a remainder of 2. 11 goes into 201. Or no, sorry, 11 goes into 20 once with 9 remainder. That doesn't work. So let's try 3. 11 goes into 3 once, or sorry, 9 times with a remainder of 4. Goes into 40 30 times with a remainder of 7. Well, that doesn't work, right? So right away we're saying we need to find a number here that gives us a remainder that's going to get me to 11, right? So what number would give me a remainder? That's what we're thinking, right? So we haven't gotten close yet, so I'm going to skip ahead. I'm going to skip to 8. So 11, and the reason why I'm doing this is the remainders aren't working to get my 11 down here, right? So it's always fun listening to a math teacher figure it out by themselves, or on their own, right? So 11 goes into 108 9 times with 9 left over. So it goes into 90 8 times, right? With remainder of 2. No, that's not going to work. 21. How about 9? So 11 goes into this with a remainder of 10. Oh. 99, so a remainder of 1, that's my 11. So here's what I did. I first figured out that this had to be a 1 and that had to be a 1. That was easy. Then the most obvious thing is to have a 0 and a 0 here, because that's going to keep my number as low as possible. And then I plugged in a 0, and I found that as I divided it, I got a remainder that didn't make sense here. So then I did 1 or 2, 3, and noticed a pattern that this digit was getting bigger and bigger. But I needed to get, with the remainder, an 11 here, and I wasn't close. So I skipped ahead to 8, which got me pretty close, but then when I got 9, I got the remainder I was looking for of 1 over here, which gave me my 11, which is divisible by 11. That one's a tough one. It is a really tough one. All right. What is the units digit? The number that is, okay. So we have 3 to the 147. And I know 3 to the first is 3. I'm only looking at the units digit. 3 to the second is 9. 3 to the third is 27. Notice only the units digit. 3 to the fourth is 81, which is just the 1. And then if I have 3 to the fifth, 3 times 1, again, is going to be 3. And it's just going to repeat, right? So that means when I have a total of 4 options. So these are the only 4 numbers it could be. And so if I take a look at 147 divided by 4, I get, and I'm looking for the remainder here, because remainders rule. That is 3, 2, that is 6, with a remainder of 3. The R3 is the thing that I want. 1 divided by 4 has a remainder of 1. 2 divided by 4 has a remainder of 2. 3 divided by 4 has a remainder of 3. Oh, just like we had up here. So that means 7 is the units digit for that number. Find the area of a trapezoid whose base is, all right, so a trapezoid, very ugly. We have base 2, base 1, and we have height. And the area of a trapezoid is equal to base 1 plus base 2 times the height divided by 2. And the reason behind this is if I were to duplicate this, woohoo! It may happen in our lifetime. I'm going to change its color. I'm going to rotate it. You don't have to remember this part, but it's helpful in understanding. Now I have a parallelogram, and the area of a parallelogram is base times height, but we only want half of it, divided by 2, and there's my base is base 1 plus base 2. All right, we'll get rid of that. All right, so we have 10 plus 6 times 5 divided by 2, 16. So 16 divided by 2 is 8. 8 times 5 is 40. Alex's average car average 24 miles per gallon. I'm going to just use a calculator on this one. So, and obviously you could do it in normal time, but I don't want to. All right. He drives 312 miles. Oops. 12 miles. He is getting 24 miles to the gallon, so that means he gets 13, he uses 13 gallons. A gallon of gas, oh my goodness gracious. Actually, I do remember back at this time gas was this expensive. I'm sure it will be again at some point, but right now it's really, really cheap. So we get 47.06. All right. 20. Find the area of a right triangle, not the wrong one, whose hypotenuse is 50 and a leg measures 48. Now, incidentally, there is a famous Pythagorean triple that is something, of course I don't remember that something, 24, sorry, there's something, 24, 25. And if I remembered what that something was, I could just, obviously this is a scale factor of 2, I could just find it really quickly. But since I don't, and you probably don't either, we're going to use the Pythagorean theorem here. So we have a squared plus 48 squared is equal to 50 squared. So 48 squared. All right. 48 squared. Now I know what 4 squared is. So we get I knew that one. No, that's not one. 50 squared. And I probably could have got that one on my own too. So we get 196. So we have a squared is equal to 196 square root, and we get 14. All right, well, that famous triangle I'm talking about is not this triangle. Shocking. Oh yeah, no, it's 7. Scale factor of 2. So there's another famous Pythagorean triple. A 7, 24, 25. Not quite as famous as the 3, 4, 5, or the 5, 12, 13, or the 8, 15, 17 right triangles. These 3 you really need to know. All right, last problem. Woohoo! From a standard deck of cards, 2 cards are drawn. What is the probability that both cards are 8? Express your answer as a common fraction. Now, we haven't done a whole lot of this in class this year, pretty much because it is covered in the 7th grade curriculum and what do you expect. But there are 4 8s in a deck of 52 cards. Each suit has 13 cards, so you have a total of 52. Excuse the yawning. All right, so that means in my first draw, I have a 4 in 52 chance, which is also equal to a 1 in 13 chance. And then on the second time I take it, and I'm assuming that I'm not replacing the card, I only have a 3 in 51 chance of getting it. Now that is equal to 1 over 17. So then, if my first event is a 1 in 13 chance, my second event is a 1 in 17 chance, the chance of them both happening is going to be, so I have to do 13 times 17. So, did I do that right? Let's double check. 17 times 13. Oh my goodness gracious. Now I'm concerned. 20, 21, 2, 3 times 1. I added them because I'm all right. I don't know what I was doing. 3 times 1 is 3. 3 plus 2 is 5. There we go. So we get to, there we go. Okay. So we get 121 out of 221 times. I will get double 8s. All right. So I hope that was helpful, and I'll see you on Monday.